So the reason why we're kind of taking a step back from video notes is because 6.1, which normally like the first lesson of a new chapter is always the easiest, this one is actually the hardest of the entire chapter. And I want to say it's one of the hardest all year, okay? We are going to be going over 6.1 for 4 days. Like we're learning the same one lesson for 4 days straight because it is that complicated, okay? It's kind of hard, I feel like, for you guys to wrap your head around. So I want to make sure that we understand it. Okay, so we're talking about exponents. So let's do number one. Let's just do this whole paper together, okay? Do you notice how now I have all of these negative exponents? All of my exponents are negative, right? So if this were like normal, normal math, not that algebra is abnormal, but if this were a normal year, you learn that like 3 to the second power is take this number, 3, but multiply it 2 times. So it's 3 times 3, which is 9. Does that make sense? Okay, so 3 to the negative 2, now that I add a negative there, it does not mean like take 3, multiply it twice, but they're like negatives. That's not what it means, okay? What it means is, the rule is when you have a negative exponent, you have to flip it. So what do I mean by flip it? I mean like you see how a number like 9 is the same thing as saying 9 over 1, technically? Does that make sense? Like 9, the whole number is 9 over 1. If I say flip it, I mean if it was on the top, it goes to the bottom. If it was on the bottom, it goes to the top. I know that doesn't really make sense, but I feel like the more we practice it, the more you'll understand it. Okay, so if I had like 7 to the negative 2, that means it's 7 squared is 49, but since it's 49, you're putting it at the bottom. You're flipping it because it's a negative. Okay, so let's do this. Yes, Tessa. Yeah, hurry. All right, so on top of your paper, please write, if you have a negative exponent. So if you have a negative exponent, your rule is you're going to flip the number, or flip the problem, or just flip it. So if it was on the top, it's now on the bottom. If it's on the bottom, now it goes to the top. So write that at the top of your paper, please. If you have a negative exponent, flip the number. If it was on the top, it goes to the bottom. If it was on the bottom, now it goes to the top. Okay, this is really complicated. I know, okay? You're probably going to be a little confused today. We're going to do it again tomorrow. You'll probably be a little bit more confused tomorrow, but we will do this for 4 days. So just please make sure that you don't give up and you're really trying to focus and pay attention, okay? All right. So let's take a look at this. 3 to the negative 2. Okay, I have a negative exponent, right? So the rule is if I see a negative exponent, I just flip it. So what I mean by flip it is 3 to the negative 2 is the same thing as saying 3 to the negative 2 over 1, right? So since it was on top of the fraction, now it goes to the bottom. Does that make sense? So it was on top of the fraction because it was kind of like a whole number, but now it goes to the bottom. So that's the same thing then as saying 3 to the 2 is on the bottom, so it's 3 times 3, because it's 3 to the second power, and that gives me 9. So my answer is 1/9. So if you wanted to double check this in your calculator, like I have, if I type in 3 to the negative 2, by the way, guys, the 2, the symbol, the exponent is right here. It's right underneath the clear. So all of you practice typing that in, okay? Because you need to know where your exponent is. So this is your exponent button. If I have 3 to the negative 2, notice how it gives me not 1/9, right? It gives me the decimal. But if I wanted to change it to a decimal, I would press alpha, y equals, and then the fourth option, F to D, fraction to decimal. And then it would tell me that it's 1/9. Okay, but my concern is though that your calculator is not going to give you all the answers, because what if your problem was like, x, y to the negative 5z? Like you can't put letters in your calculator, so you still have to know how this works by hand. Okay, so by hand, if I wanted to solve this problem, I would say, okay, x, does that have a negative exponent? No, so it stays where it is. Y, does that have a negative exponent? Yes, so you flip it. Since it was on the top, now it goes to the bottom. So it's y to the 5th now. And then z, does it have a negative exponent? No, so it stays where it is. So that's actually this answer. Like if you type that in your calculator, let me show you. So if I type in like an x, I don't even know where the letters are, y to the -2, and then z, where is it? Z right there. So I just, oh, no. Need to get out my fraction. Z, like that. Look, I mean, my calculator says 0. It doesn't even know what to do with that, right? Your calculator's not that smart. So you still have to know how to do this by hand. And again, if this doesn't make sense to you, that's okay. We're practicing that today. Okay, but let's just start with numbers. All right, so number 2, I have 2 to the -4. Negative exponent tells me to flip it. So since it was on top, now it goes to the bottom. Notice how when it flips, the negative disappears. Do you see how it's no longer -4? That's the rule. Once you flip it, the negative disappears. Now you can do the math. It's 1 over 2 to the 4th is 2 times 2 times 2 times 2. And you really don't have to do it in your head if you don't want to. 2 to the 4th, just type that in your calculator, is 16. So it's 1/16. Okay. Now let's make it even more complicated. The reason why number 3 is more complicated is because you have that parentheses right there. Okay, so since I have the parentheses right there, well, first of all, I see that I have a negative exponent, so it's over 1. So since it has a negative exponent, the rule is I flip it, right? It was on the top, now it goes to the bottom. So on the bottom, should I write 3 to the 3rd or -3 to the 3rd? -3. So here's the rule. When I flipped it, the negative exponent went away, right? When I flipped it, this -3 as an exponent went away and it turned into a +3. But my base, this main number is called the base. My base still stays the same and it's still -3. Yes, Luke?
Is that always the case?
That is always the case. If it's in parentheses, you have to say it's all of -3. So all of -3 goes to the bottom. So really what you're doing is you're saying it's 1 over -3 times -3 times -3. Because if you forget a negative, then maybe that messes up your positive negative answer part. So when you type this in your calculator, then do not type this, -3 to the 3rd power. Do not type that in. Because if you type that in, you get that. Oh, fine. Oh, darn it. For this one, it's the same. But this way, you have to put it in parentheses. Okay, I know you still get -27. Let me give you another example. That was a bad example. So parentheses make a huge difference this chapter. This is what I'm talking about. If you have -2 to the 4th power and -2 to the 4th power, do you see the difference? One's in parentheses, one's not. If I were to type this in the calculator, -2 in parentheses means I'm going -2 times -2 times -2 times -2. That gives me +16. But this one, it's -2 to the 4th, which is 16. So like if I were to type that in my calculator, -2 to the 4th, you see how it gives me 2 different answers? So that's why parentheses make a huge difference. This one doesn't because you had an odd number with an odd number of negatives. But anyways, my point is, this is the same thing as saying -2 times -2 times -2 times -2. Okay, that's why it's +16. This one is just do 2 to the 4th, which is 16, and then stick a negative in front. So if you have no parentheses, all you do is you just stick a negative in front. Okay, let's do the next one. -1 to the -5. All right, so first of all, it has a negative exponent. So if I have a negative exponent, then it flips, right? That's the rule. So it goes to the bottom because it was on the top. Notice how the 5 is now a +5, no longer a -5, because once you flip it, then your symbol goes away. Yes? Hurry. So when I put this in parentheses, is it +1 or -1? -1, right? Because it was all of -1 to the -5th power. So that's why you're going -1. So -1 times -1 times -1 times -1 times -1. Okay, you don't technically have to do this in your calculator, If you do want to do it in your calculator, make sure you put it in parentheses, -1 to the +5 like that, okay? Because it would sometimes, 50% of the time, make a difference. Okay, well, negative times negative times an odd number of times. Is that going to be a positive or negative answer? Negative, right? Because negative negative equals positive, negative negative equals positive. You still have a negative left over. And then 1, 1, 1, 1, 1, that still equals 1. So it's 1 over -1, which is just -1 as your answer. Okay, next one. Something to the 0 power. So remember how we said, like, PEMDAS, exponents come first. So if I were to think of PEMDAS, exponents come first before multiply. This technically is a multiply problem, right? Because isn't it -1 times 7.2 to the 0? So PEMDAS tells you do the exponent first, then multiply by -1. Okay, so don't think of my answer as just being negative because you see a negative there. So anything to the 0 power, what did that equal?
0.
No.
1.
1. So anything to the 0 power, 7.2 to the 0 power, you can't see, equals 1. 56 to the 0 power equals 1. 1 million to the 0 power equals 1. Anything to the 0 power is always going to equal 1. Okay, so for this one, 7.2 to the 0 power equals 1. And then do you see how the negative is on the outside, so you just stick it in front. Okay, I'm going to add a bonus problem here. Do this. Can you write right underneath number 5? Do this. -7.2 to the 0. Do you see the difference in the two problems? One of them, the negative was on the outside. One of them, the negative is on the inside. So I know that anything to the 0 power equals 1. But here's my question. Is this +1 or -1? +1. Okay, so do you see the difference? The reason why this one is +1 is because it's saying anything which is -7.2 to the 0 power is going to equal always 1. But the reason why this one was -1 was because it was on the outside. If it's on the outside, you just stick it in at the very end. So notice how I type this on my calculator. If I have negative parentheses 7.2 to the 0 power, I get -1. But if I have -7.2 to the 0 power, I get +1. So there is a huge difference with parentheses and where you're putting your negatives. What about this one? -7.2 to the 0. I have no parentheses this time. Is this +1 or -1? -1. The reason why this is -1 is because PEMDAS is telling you to say 7.2 to the 0 and then stick a negative in front. So this negative, because there's no parentheses, always just tells you to just put it in the very end. Okay, so this one, try it yourself, okay? Maybe take a look at number 1, take a look at number 2, take a look at number 3 to help you through it. But try this one by yourself. And don't write your answer as a decimal. I know that if you just type it in your calculator, you're going to get a decimal. Please learn to write it as a fraction, because once we get to variables, we're going to have to do it as a fraction. Like once we get to number 10, it's going to become super complicated. Does anyone think they know this answer for number 6? Tessa? 1 over 64 is my final answer. Let me show you how we got this. Okay, negative exponent. If I see a negative exponent, you know the rule is always to flip it. So if I'm flipping it, I have 1 over 4 to the 3rd. You see how the 3 becomes a positive? Because I flipped it. So after I flip it, it becomes positive. The 4, do I really need parentheses around it? No, because it's not a negative. But I can just leave the parentheses there since they gave it to me. Okay. That's the same thing as saying 1 over 4 times 4 times 4. Or really, you could just say 4 to the 3rd is 64, so it's 1 over 64. Okay, now let's do number 7. Evaluate each expression for the given values of the variable. So x, they're telling me to plug in as 3. So they're really telling me to say, okay, what is 3 to the -2? That's just what they're asking me, right? I'm just plugging in this number for x. Okay, so try this. This is Very similar to numbers 1, 2, and 3 again. Someone online, do you think you can tell us the answer? Unmute or type it in, please.
Or 1/9.
Thank you. So my answer is 1/9. Please don't write it as a decimal. Always leave it as a fraction for this chapter, okay? So 3/2, or 3 to the -2, negative exponent tells me to flip it, right? So that's 1/3 to the 2. Well, 3 to the 2 is 9, so it's 1/9. Okay, even more complicated. I'll do this one with you. M is 2, so I have 2 to the 0. N is 3, so it's 3 to the -3. This is what this problem says. Okay, when you attack this, because we have a lot of stuff going on, think of it as like its own separate entity. This is one thing, this is another thing, and then just combine your answers together. Okay, so if I do this, 2 to the 0, what is 2 to the 0? 1. Does that make sense? Like 2 to the 0 is just 1. Anything to the 0 is just 1. Now, I don't see any symbols between. So if you don't see a symbol, what is always your symbol in between? Multiply, times. So it's really saying what's 1 times, okay, 3 to the -3. 3. So it's 1/27. And how do you get 27? Because it's 3 to the 3rd. You see how negative exponents get flipped. Since it was on the top, now it goes on the bottom. And so 1 times 1/3 to the 3 is just 1/27. So that's my final answer. Okay, so let's do number 9 then. For number 9, I have 5. And then R, they're telling me, is -2 to the -4. Okay, when I set this up, I did something wrong. Does anyone know what I did wrong, Emily? Yes, it makes a huge difference. If I don't put a parentheses around the -2, then essentially I'm saying to myself, do 2 to the -4 and then stick a negative in front. And that's not the case. I have to put a -2 with the parentheses around it because it's saying all of -2 is to the -4th power. Okay, so for this answer, let's put it all over 1 so you know that you have to flip it. Okay, treat it as 2 separate problems. You have a 5, and then you have -2 to -4. So 5, does that have a negative exponent? No, so it just stays the same. There's nothing that I need to do with the 5. So 5 just stays the same. It was on top, keep it on top. All right, -2 to the -4. It does have a negative exponent. So do you see how it goes to the bottom? It gets flipped. So at the bottom, I write -2 to the +4. So does anyone think they have the final answer, Luis? 5/16, right? Because the 5 is still there. -2 to the 4 is +16. Notice how if I did not do what Emily told me to do, if I did not put it in parentheses and I just wrote -2 to the 4th, that would have given me -16, which is wrong, right? Because this one without the parentheses would say, what's 2 to the 4? 16, and then stick a negative in front. Whereas this one says -2 times -2 times -2 times -2, which is +16. So this is my answer, 5/16. I know this is weird, guys, okay? The more you practice it, the easier it'll be, I promise, okay? You're just not used to it because it's just a weird topic. All right, number 10. So treat it as 2 separate entities. You have a 4, and then you have an x to the -3. So normally when I do these problems, I always like draw a fraction bar. So I know like what goes on top, what goes on the bottom, blah, blah, blah. All right, number 10, the 4. Does it stay on the top or bottom? Top. You see how 4 does not have a negative exponent? So 4 just stays. X to the -3, top or bottom? Bottom, x to the 3rd. There's nothing for me to solve because it's an x. It's not a number. So that's my answer. So the rule is if you have a negative exponent, you have to simplify it. This negative exponent is not simplified when it's written like this. You have to flip it. Ooh, okay. Number 11. 5. Top or bottom? Top. It stays on the top because it was not a negative exponent, so leave it as it is. Okay, now b to the negative 2 is at the bottom. So when I write my final answer, does b squared go top or bottom? Do you see how it was a negative exponent on the bottom? So since it's at the bottom, you flip it so it goes to the top. But wait, remember the negative disappears. Once you flip it, the negative 2 becomes a positive 2. So there's nothing at the bottom anymore. Is that okay?
No.
Yes. You could just write a 1 over it, or you could just leave it like that. That's fine. Okay, number 12. M to the third, top or bottom? Top, because it's not negative. N to the negative 4, top or bottom? Bottom. Notice how it's n to the positive 4 now, right? Once you flip it, the negative goes away. Ooh, p to the 0, what does that equal? 1. So 1 times something, timesing something by 1 basically just disappears, right? If I multiply it by 1, I can say times 1, but timesing it by 1 just stays the same. So that's my final answer. Okay, number 13. Try this one yourself. Does someone think they know? Read.
2k to the 4th power.
No. Ashlyn?
2 over K4. But
Closer, but no. Vaughn?
1 over 2 times
Okay, 1 over 2k to the 4th, right. Okay, so this is how I think it to myself. K to the negative 4, it was on top, it flipped because it has a negative exponent, so now it's at the bottom, k to the 4th. The 2 did not have a negative exponent, so if it didn't have a negative exponent, it stays where it is. It's at the bottom, so it stays at the bottom. Now I have this gaping hole at the top. Well, I can't leave like a blank at the top, so I always use 1 as a placeholder. Like for this one, if I had nothing left on the bottom, you could always put a 1 at the bottom, but having a 1 at the bottom, isn't that the same thing as saying 5b squared? So I really didn't have to say over 1, like that didn't matter. But this one, it does make a difference to say 1 over. So this is my final answer. I know it's weird, guys. The more you practice, the easier it'll be. Okay, this one, number 14, try it. Jack, what do you think?
F4 on the top and B1 on the top.
So this is the answer. If you really wanted to put it over 1, sure, but it's really not necessary, right? So just F to the 4, G to the 1. Or G to the 1 is the same thing as just saying G, right? You really don't even need to the 1 power. So F to the 4, it was a positive exponent. It stays on top. G to the negative 1, it was negative exponent, so you flip it. Since it was on the bottom, now it goes to the top. There's nothing left on the bottom anymore, so I could put a 1 or just realize over 1 is the same thing as just saying the whole number. Okay, number 15, try it. Somebody different? Do you think you have this one? Owen, what do you think?
R6 and then S2.
Is S2 on the top or bottom? This is my answer. Good job. Okay, R to the 6, positive exponent, stays where it is. T to the 0, anything to the 0 equals 1, so it basically disappears. When you multiply by 1, it disappears. S to the negative 2, negative exponent, it flips. Since it was on the bottom, now it goes on the top. You really could put over 1 if you wanted to, but that's the same thing as just saying this. Okay, yes, Emily.
Does it matter like what order you put like?
Kind of. Okay, Emily asks a very good question. What if you put S2 R6? Is that okay? Technically for 8th grade, I would say, yeah, sure, that's fine, because it's just multiplying between. But since you guys are in pre-AP, I kind of want to teach you guys the rule. Whenever we write things, we want to write them in alphabetical order. So in the alphabet, R comes before S, F comes before G. Okay, so don't put like G1, F4, because technically we want to put it in alphabetical order. And then one more rule is if you have numbers and letters combined, always put the number first and then the letter. Always put the number first and then the letter. Yes, Reed?
if there's like 5B on the top and then there's like 6C on the bottom, do you still, like how would that work?
Yeah, so if you had like 5B on the top and 6C at the bottom, well, I'm just talking about like the same level. So in the top level, numbers come first, then letters. On the bottom level, numbers come first, then letters. Does that make sense? So there's no such thing as you can't like combine them because one's on the top, one's on the bottom. So I'm basically just saying if you have an answer that's like A, 2, C, 3, D, 4, B, 6, 10, like don't write it like that. Write it as 10, A squared, B 6, C 3, D 4, right? The number comes first and you have A, B, C, D. Okay, so put it in alphabetical order. Okay. 16 and 17 we're going to skip, okay, because you're kind of doing that on the back side. So back side, we're not going to do all of them, but hopefully this back side is much easier than the front side because you technically learned this stuff last year. And I think, well, maybe last year is the first time you learned it, but you definitely learned it in 8th grade math. Okay, powers of 10. So the powers of 10 means you always start with 1. So if you have 10 to the negative 2, start with the number 1 and then put a decimal. Okay, negative 2. Negative means backwards. I'm going to go bloop, bloop, go backwards 2 times. As a placeholder, remember what number I put in? 0. So my answer is 0.01. My decimal has moved 2 backwards, so now it's 0.01. Okay, number 3, 10 to the 0. Anything to the 0 equals 1. All right, 10 to the negative 1. So remember, whenever you have 10 to the something, always put 1 and then 0. Start from there. Negative 1, so am I going forward or backward? Backward 1 time because it's the negative 1. Bloop. So my final answer is 0.1. Okay, which is very different than numbers 2 and 6 because for number 2, okay, still a power of 10. So I still start with 1 and then a decimal. But it's to the 3rd power. So I'm moving 3 times, 3 loops, but forward or backward? Forward because it's a positive, right? So bloop, bloop, bloop. So I add 3 zeros as placeholders. My final answer is 1,000. It's not 1.000. 1.000 is still 1, right? So move your decimal all the way to the end. It's 1,000. You really don't need a decimal at the end, but I'm showing you like you're physically moving the decimal. Okay, so for number 6, start with a 1 and a decimal. How many loops am I drawing? Sorry, number 6. We're doing number 6. 7 loops, forward or backward? Forward because it's positive. 1, 2, 3, 4, 5, 6, 7. Draw a nice big fat loop so you are very clear how many zeros I have to add. My final answer is 10 million. That is a lot. Can you believe that there are people out there that like earn as their salary $10 million a year? I can't even imagine what I would do with $10 million in my life, much less 1 year.
$1 billion a year.
I know.
That's
Like, what do you do with all that money? Like, you can buy all the cars and the houses and the vacations you want, and you're still going to have so much money left over.
well, the reason they get that money is because they invest. So
That is
they're
true.
doing more investments.
That is true. Okay.
When you've got $10 million, why bother investing? Because it makes you a lot more money.
Yeah, you get even more, and then people get greedy. All right, let's skip number 7, 8, 9. Let's do this one. Okay, now we didn't do number 4. So let's skip 7, 8, 9. Let's do number 10. So for this one, now I start with 22.6, right? And I'm moving my decimal. How many times? 4, because it's to the 4th power, left or right? Right, because it's positive. So 1, 2, 3, 4. So I'm actually just adding 3 zeros as placeholders. My final answer is 226,000. Does that make sense what I'm doing? Hopefully this is kind of a reminder from last year. Yes, JC?
Why only put like a 1 and move it and not like the 10?
Okay, good question. So JC's saying like, if I start with 22.6 here, why am I not starting with 10 here? It's just the rule. I honestly don't even really have a good answer for you. When you have a base of 10, you just always start with 1. Yes, Luke?
It's like amazing, like 100 or 1,000, you start with like 10 and 100.
Yes. And we would never ask you that because that's just being complicated. No one would ever really ask you a base of 100 or 1,000. That's just not like the standard form. If you really wanted, like if someone really gave you like, what is, 100 to the negative third power, just type it in your calculator. Okay.
About 100 to 100 power.
Yeah, so just type it in your calculator. Okay, so let's do one like number 11 then. Okay, so I have 5.28. And how many loops am I going to draw? 3, forward or backward? Backward because it's negative. So start from your original decimal wherever it was. So between the 5 and the 2. So 1, 2, 3. That's where your new decimal is. And then add zeros as placeholder. So you have 0.00528. That's your answer. Okay, what do you think? Do you think you need more practice like 12, 13, 14, or do you think you're okay? Okay, let's try number 15 because 15 is tricky. Or people do get tricked. How about that? It's not hard, but people do end up getting tricked. Okay, so I know I have to draw 4 loops. I know I have to go forward. I know I start with 6, but I don't see a decimal in this problem, so I don't know where my decimal is. And this is where kids get tricked. Ashlyn?
I was gonna say no.
Yeah.
So it's a positive, it doesn't have a decimal in the symbol, so just put it like after.
Yeah, exactly. 6 is 6 point, right? Think of 6 as $6. $6 is 6.00. So it's not 0.6. 0.6 is very different than 6 point. So here's your decimal. Now you move it 4 times. So you're actually adding 4 decimals to get 60,000 as your answer. Okay. All right. Now let's write it in scientific notation. You're going backwards. They give you the answer and you have to write the actual, like, what is the problem? So what I normally tell my 8th grade math kids is I say, okay, cover up all your zeros. For it to be written in scientific notation, you have 1 number and then 1 decimal and then everything after. So your first number is 4 and then you put a decimal and then everything after, which is just 0.5. It's not 45. It's not 0.45. This scientific notation always has to be between the numbers 1 and 9. Okay, so 0.45 is too small, 45 is too big. It's 1 number, 1 decimal, everything after. And then times 10 to the something. So if I said 4.5, here's 4.5. I'm moving it 1, 2, 3 to the end, so it's times 10 to the third power. Okay, so number 17, cover up your zeros. So I write the first number, which is 6, and then I write a decimal, and then I write everything after, so 56. So do you see how it's 6.56? It's not 65.6, it's not 0.656. It's always 1 number, 1 decimal, everything after. Then times 10 to the something. So 6.56 is right here. How many loops do I draw? 6 of them. So it's 1, 2, 3, 4, 5, 6. So it's times 10 to the 6th power. Okay, so number 18, cover up your zeros in the front this time. Right, the first number you see, 2, and then a decimal, and then everything after. Oh, shoot, that's just 2. There's nothing after. So it's just 2 times 10 to the something. Okay, the reason why I put the decimal after the 2 is because of what Ashlyn said, right? It's good to know that if you have a number, a whole number, it's always the decimals after. So now you know where your decimal is that you should put, because it's not 0.2, it's 2 points. And then go backwards. You're not going backwards to the very end of the problem. You're going backwards to your original decimal. So to my original decimal, I'm going 1, 2, 3, 4, 5. Just 5 loops, right? Not 6, 5. So it's 10 times 10 to the negative 5 because I'm going backwards. Okay, so try number 19 by yourself, and that is our last one. Does anyone think they know this one? Reed, what do you think?
2.03 times 10 to the third power.
So close. Negative, right? Because you're going backwards. Okay, so cover up your zeros. 2, and then a point, and then everything after. 03. You still have to include the 0. It's not 2.3, it's 2.03. So here's your decimal. 1, 2, 3. Go back to your original decimal, not the end. So it's -3. You're going backwards. Okay, so your homework.